Hi everyone. So in this video, I'm going to be talking about examples of momentum, impulse, and basically these things. So first and foremost, the first example could be, what is the momentum of a 1,500 kilogram car that's traveling down the road at a speed of 20 meters per second. So there is this car that's traveling by 20 meters per second. So that's the velocity of the car. And here is the mass of the car is 1,500 kilograms. So momentum is mass times velocity of the car, 1,500 times 20. That gives you 30,000 meters per second. One thing I forgot to mention is the units of momentum. Since mass is in kilograms and velocity is meters per second, units of momentum turns out to be kilograms, meters per second, and there is no nickname for it. So it's just kilograms, meters per second. So that's the first question, which is essentially just using the definition of momentum to see what the momentum of this car would be, and so that's basically that. The second question deals with the same thing, but in a different language. It says how fast, so velocity, how fast would you have to throw a baseball of mass 150 grams to give it the same momentum as a 20-gram bullet that travels by 500 meters per second. So the question is how fast this baseball should be thrown such that the momentum of this guy, the baseball, is the same as momentum of a little bullet with mass of 20 grams, but with velocity of 500 meters per second. We want this momentum of the baseball will be the same as the momentum of the bullet. So let's just write it out. I write out first the momentum of the baseball that I'm looking for, the mass of the baseball times the velocity of it. Mass is given in grams, so you need to be careful to convert it to kilograms, and then the velocity that I'm looking for. This gives me the momentum of the baseball, which I want to be the same momentum as the bullet. Momentum of the bullet is mass of the bullet times the velocity of the bullet. It's 20 grams, so converted into kilograms, times the velocity of the bullet, and that gives you 10 kilograms meters per second. So 10 kilograms meters per second is the momentum of the bullet, which I want this number to be the same number as the momentum of the baseball. Okay, so let's equate 10 to the momentum of the baseball that I'm looking for. So let's just multiply both sides by 100 equals that. Then that gives me 1,000 equals 15V. And then let me just... So that velocity turns out to be 66.67 meters per second. So it means that if I throw the baseball that has mass of 150 grams in there by velocity of 66.7 roughly meters per second, the momentum of my baseball is, the number for it is the same momentum as the momentum of a bullet that's only 20 grams, but it goes by 500 meters per second. So this is the other type of momentum questions that you could be given. The other momentum question deals with impulse. So it says, what impulse is needed to stop? So the impulse that I have to, like the impulse that's needed to stop a 1,000-kilogram car that's traveling at 15 meters per second. So I'm looking for the impulse that I have to exert on the car so that I stop this car of 1 ton, like 1,000 kilograms, at 15 meters per second. So the car is essentially going, the car by mass of 1,000 kilograms is going by 15 meters per second. This car wants to come to a halt. This car wants to come to a halt, and I want to see what would be the impulse that's needed for this for stopping the car from moving at 15 meters per second. So impulse is delta P. It's also Ft. So here I have mass velocity. So I better take care of this. I better use impulse. I better figure out the impulse using delta P. I don't have force or anything like that. So I calculate impulse through delta P, which is change in momentum. What is my first momentum? Let's write it out. The first initial momentum was mv1. So 1,000 times 15. And then second momentum would be mv2, which is m times 0. So that is 0 itself. Hence, delta P, which is change in momentum. Change in momentum is second minus first. Second is 0 minus first is 1,000 times 15, which gives rise to minus 15,000 kilograms meters per second. So this much impulse is needed. 15,000 kilograms meters per second is needed to stop a car that's traveling at 15 meters per second. So that's another example that deals with momentum, impulse, and whatnot.